Evening class, welcome to our presentation on Chapter 16, Design Patterns. As I hope you all are aware, design patterns is a very important part of the syllabus. So this is quite important stuff that we'll be covering tonight. It is something you need to know quite well because you will definitely get multiple questions in the exam about design patterns, and you will also have to implement them in your next two assignments, in assignment 2 and 3. And before we get going, I just want to update a few things. Okay, I've had a couple of requests about assignment 1 and exercise 5, so I'm going to do an extra class next week. Wednesday, I'll send out a notice. It'll be purely code-based. We'll have a look at the solutions to assignment 1 and also the solution to exercise 5, the models and views. Other than that, our next class will be in 2 weeks' time. That's on the Wednesday, the 29th, when I'll be going through assignment 2, which you will have had a couple of days to look at by then. Then, as before, please do the exercises 6, 7, and 8. Very important for assignment 2. You will get questions in the assignment on all that stuff that's covered in exercises 6, 7, and 8. And as I said before, assignment 2, there's a lot more depth to it than assignment 1, so it's going to take you longer. You can't afford to waste time or spend your assignment time trying to learn how to do things, so please do the exercises as preparation beforehand. Then while I'm speaking about the exercises, exercise 5, I've uploaded a revised solution. It turns out there was a problem in there and a couple of lessons learned. When I tested it, I didn't test the previous parts from the earlier exercises. I only tested the model and the view that were added. And I didn't test adding a new customer from scratch because, as far as I knew, that custom input part worked very well from previously. But as it turns out, adding the model broke that first part because previously the address in custom input, it didn't matter how many fields it had, but when the model was added, it required exactly 4 fields for the address. So if anybody added a customer and didn't add 4 fields, the program crashed. So I've just made an alteration in there to pad the string list for the address if it's less than 4 fields, so it'll always be a minimum of 4. The problem was actually solved in exercise 6 because validation was added and then became impossible to input invalid data. So that solved the problem. But as far as exercise 5 was concerned, a lesson learned there is you need to test your whole app and not just parts that you add on, because adding something on can break something that worked before. And also, just a reminder then about how important validation is. If the input had been validated, the program wouldn't have crashed. And also giving user feedback. If users had been told that the address required 4 fields, the problem wouldn't have been as pronounced. So I think there's a few valuable lessons to be learned from that. But anyway, exercise 5 solution should now work okay. And that problem, as I say, is in any event solved with exercise 6. Then assignment 1, I'm sure you're all desperately keen to get your marks. Dr. Pilkington says he's working on it, but he's got 401 assignments to mark, so it's going to take him a while. It's unlikely to be available before assignment 2 opens, but he says he is trying to get the results out before the close of assignment 2. And just speaking about the 401 submissions, slightly strange, because there are 498 students registered for COS3711, but only 401 submitted assignment 1. So I'm not sure what's going on there. But anyway, are there any questions on anything so far? No. Okay, then let's get into it. Right, design patterns, the outcomes. Okay, you need to understand, identify, and implement. In other words, you need to know everything about the following design patterns. The factory method pattern, that one comes up often. The abstract factory is just multiple versions of the factory method in one, but we'll have a look at that shortly. Singleton, also very important, comes up often. Memento pattern, also important, comes up often. Facade pattern, not so important. You don't need to know that, or you need to know about it, but probably not the detail. Strategy pattern, that came up in the exam last year. Then the adapter wrapper pattern, also you don't really need to know the details. It's not a particularly important one. And then serializer, we've done before, so I'm not going through it tonight, but that's one that comes up often you need to know about. So just to summarize the ones you really need to know about: definitely factory method, abstract factory, singleton, memento, and strategy, and and serializer. The facade and adapter is sure you have an idea of what they are. Sorry, I'm getting a bit of echo here. Okay, I'll try turning my sound down, hoping that'll sort it out. And then references, which you must have a look at. This book, Design Patterns, Elements of Reusable Object-Oriented Software, by the Gang of Four, as they're called. Please read up on each of these design patterns in there. That's, as I say, the first hand, that's where these design patterns originated from. And then recommended head first design patterns. So this gives an alternative, more sort of easier reading view on the design patterns, but it's worth having a look at. And as we said before, this book will in fact be the prescribed book for next year. So that briefly is the introduction. Okay, what is a design pattern? A design pattern is a general repeatable solution to a commonly occurring problem in software design. They are high-level abstract templates and that can be applied to particular kinds of design problems. Right, so a design pattern is a methodology. It's not specific code. It's just a general means to solve specific problems that tend to reoccur in software design. Although, of course, if you look on the internet, you will find plenty of coded examples, but a design pattern is not really the code. It's really just a general solution or approach to solving specific problems. And you get three different types of design patterns: creational patterns, which make a system independent of how its objects are created, composed, and represented. These ones are the factory method, the abstract factory, and the singleton. So those are three creational patterns you need to know about, as particularly factory method and singleton. Behavioral patterns. They provide effective communication and assignment of responsibilities between objects. The ones you need to know about are memento, strategy, and serializer. And then structural patterns deal with the assembly of objects and classes into larger structures while keeping the structures flexible and efficient. That's the facade and the adapter, also known as the wrapper pattern. So those you don't really need to know in detail, but just read up on them and make sure you have an idea of what they do. But I doubt very much you'll get any detailed questions on them. Then this is from the book by the Gang of Four. This is how they describe the design patterns in their book. Design pattern has four essential elements: the pattern name, which they call a handle, and that's used to describe a design problem, its solutions and consequences in a word or two. For example, singleton, that sort of gives you an idea of what the design pattern does, or factory method, that gives you an idea of what the design pattern does. Then the design pattern describes a problem. In other words, it describes when to apply the pattern. It explains the problem and its context. And so if you look at their book, you will get more information about that. And also provides a solution that describes the elements that make up the design, their relationships, responsibilities, and collaborations. Remember that a pattern is a template. that can be used in many different situations. It's not a concrete design or implementation. So as said, the solution, the design pattern solutions are just general methodologies. They're not absolute specific concrete rigid designs. They're more a suggestion on how to solve problems. Then quite an important part is the consequences. The results and trade-offs of applying the pattern, which is critical for evaluating design consequences. So in the real world, if you're designing software and you're thinking of implementing a particular design pattern, it would be worth your while to have a look at these consequences, because there may be some negative aspects to implementing some of them. So it's something to bear in mind when deciding whether or not to implement a particular design pattern. Sorry, I'm just a bit distracted here about these late guests unable to log in. And there's one here which doesn't have a button to press. I don't know what to do about it. Okay, looking at specific design patterns. The factory method pattern. Right, the intent of the factory method is to provide an interface for creating, or instantiating is the correct word, objects in a superclass, but allows subclasses to actually create the objects. That is in fact the classic factory method. There are variations of it, and we'll actually be looking at a more simplified implementation of that classic factory method, where we don't in fact use an abstract base class, because it's not really necessary, because it's a one-on-one relationship. But just bear in mind that in the classic factory method, there is an abstract base class. Although that one, as far as I'm aware, is not used that much more. The what's known as the parameterized factory method is used. It's a simpler variation. Okay, applicability provides a common interface for instantiating related objects. The responsibility for creating objects is transferred to a separate factory method class. This is quite important when you bear in mind the single purpose principle.
Sabbath, if you go to Israel, you have cold food for.
Remember the single purpose principle, you separate object creation from object use. The other thing that the factory method does is, if you have an application and you need to instantiate objects in various different parts, it collects it all together in one place. So your object instantiation is all done in one place instead of being split up in separate places around your application, which makes it much neater and tidier and easier to maintain. Then some comments, and this refers to the classic factory method. It makes extensive use of abstract base classes, inheritance, and polymorphism. So the parameterized factory method that we're going to use doesn't really use the abstract base classes, but we do use inheritance and polymorphism. Then the variations, I've already mentioned this, but let's just go through it again. The abstract base class is not always used. Then the gang of four, they refer to this parameterized factory method, which is a simplified version of the classic factory method. And then the more complex implementations of this factory method lead to the abstract factory pattern, which we'll look at in a bit of detail just now. Then your prescribed book, there's a comment there that the abstract factory pattern is the factory method with an abstract base class. That is not correct. It's more complicated than that, and we'll have a look at that. I might as well deal with this while we're here now. The prescribed book, chapter 16, is probably more or less the worst chapter in the book. There are a number of errors, or should I say inaccurate items in there, and I'll mention some of them as we go through. But just do read through chapter 16, but don't spend too much time on it. Just get an idea of what's there. But rather look at other sources, and particularly the prescribed book, for information on these design patterns. Okay, then looking at the classic factory method, there's generally 4 types of classes that go with it. There's your product class, which is the abstract base class for the products. But those are the items that the factory produces. And in fact, you will generally always have an abstract base class here with inheritance. You normally have more than one concrete product. Then the concrete product is the concrete class that implements the abstract class. And as I say, you'll generally have multiple concrete classes there. Then the creator, and that is optional. The abstract base class for the factory, this part of the creator, that's the factory part of it. As I say, this abstract base class for that is optional, and in fact, more often than not, it's not actually used. You then get a concrete creator. So that's actually the factory. That's the concrete class that implements the factory method, and it returns a pointer to your product. So this probably makes more sense if you code an example, but that is the basics of the factory method. Then this example is from the video that's available on my Unisa. This is, in fact, what's known as the parameterized factory method. Again, you have your abstract product class here. In this case, it's bread. And you have 3 concrete products: white bread, brown bread, and whole wheat bread. This one does show an abstract factory class, but you don't actually need that because there's no purpose in having inheritance with a one-to-one relationship. So you can actually leave out that abstract bread factory and just go straight to your bread factory. And that returns pointers to each of these concrete products, depending on which one is required. What happens is the client calls the method from the factory, and it passes an argument which describes which types of concrete product you want, and the bread factory then instantiates that with new and returns a pointer to one of the concrete classes. And here are some code examples. Okay, this block on the left here is the code that's in our client application. In this example, it would have a bake method. So you instantiate a bread factory. You then declare pointer to white bread and declare pointer to brown bread. And your white bread then is assigned the value of your bread factory, and you call the make bread method that's in your bread factory, and you pass it the argument, in this case white bread. If you want brown bread, you call the make bread method from your factory, and you pass it the brown bread argument. And once you've done that, you can then do something with your white bread and brown bread. So let's just look at this make bread method. The panel on the right, this is in our bread factory, which is the blue block over there. You have a make bread method, which takes a string parameter, and it returns a pointer to your abstract base class bread. And this is where the parameterized method comes in. If the bread name is equal to white bread, you return new white bread. Also, if bread name is equal to brown bread, you return new brown bread. And it's important to always have a default case, return null pointer, otherwise you end up with problems. So that is the factory method. It's actually quite simple. You just call the make bread method from your factory, give it an argument of whatever kind you want. That just selects the appropriate one using nested if-else statements, and then returns the new bread type of whatever kind is required. So the factory method is actually quite simple and straightforward. If you haven't looked at this video yet, it is available in additional resources. I'd suggest you have a look at it. It does go through this in more detail. So it's not a very difficult design pattern. But as usual, I think you just need to code an example and you'll have a better idea of what's going on. Any questions on that? No, okay, so hopefully it's all straightforward. Okay, then the abstract factory pattern. Okay, the abstract factory pattern is actually just multiple factory methods together. What it introduces, sorry if I just want to go back, in the factory method pattern, there is this optional base class for your factory. In the abstract factory pattern, you have to have that abstract base class for the factory, but then you have multiple factories. And then along with multiple factories, you have multiple products. As on the right-hand side, I see there's the abstract product A and then the abstract product B. So all the abstract factory pattern really is multiple factory methods put together with multiple products, and I mean multiple factories, and then multiple products. So it's just a bigger factory method, if you like. And that's really the only difference between them. Is with the abstract factory, the abstract factory class becomes compulsory because you have multiple inherited factories. And then instead of just the one factory, as in the factory method, you have multiple factories, and each of those factories has a particular range of products that it produces. So the abstract factory, although it's slightly more complicated than the factory method, it's really just multiple factory methods put together, and the abstract factory class is no longer optional, it becomes compulsory. So there shouldn't be any difficulties with that. Once you understand the factory method, moving on to the abstract factory shouldn't be particularly difficult. As I say, it's just bigger and better. Multiple factories with multiple products. Whereas the factory method, you only have a single range of products and a single factory. Abstract factory, you have multiple factories and multiple product ranges. And that really is the only difference between them. So I assume there's no questions about that. Okay, now on to one of the fun ones, singleton pattern. And here we make extensive use of the keyword static. So you need to know a bit about how static works. Okay, static, when applied to class members, declares members that are not bound to class instances. They're not associated with any object, and they obey the class member access rules, private, protected, and public. So if you make a class member static, it belongs to the class and not to any particular object in the class. And that is what distinguishes static members from the other. Okay, then looking more specifically at static methods. The static keyword is only used with the declaration of a static member, not with the definition. So you don't use it inside the class body, you only use it in your header file. Once you get to your source file, you don't put the keyword static in front anymore. Then outside the class, you access static methods using the scope resolution operator. Here's an example, my class, and then the static method with the scope resolution operator. And you do not have to instantiate an object of the class in order to be able to access a static member. So you can access your static members by using the scope resolution operator with the class name without instantiating an object of the class. So just remember that, please. Static, you don't actually need any objects, and that's because your static members belong to the class and not to any objects. And remember, if you have static methods, they can only access static data members. And that's because there's no this pointer when you use static. So static method cannot access ordinary data members. They must both be static, and we'll be looking at the reason for that now. A complication with your static data members: a static data member must be initialized outside the class. And that is a static data member of the class. I'm going to look at the variation in the next line. But if you have a static data member in your class, it must be initialized outside the class. The normal place to put that is at the top of your source file, but it must be outside of the class. You cannot initialize it inside the class. Then a static local member, in other words, one inside a method. And this is very important for the singleton pattern. It is initialized the first time control passes through the declaration, and it's then skipped on all further function calls. And it retains its value between method or function calls. So this is a very important distinction for static local members. It's initialized first time control passes through the declaration. In other words, the first time the method is called, where it's declared in, and it's then skipped on all further calls to that method. But it retains its value between method and function calls. In other words, it's not destroyed when the method goes out of scope. It retains its value and it continues to exist. So that is very important to understand that behavior, because that's very much how the singleton pattern works. Then in general, static memory is allocated when a program begins and deallocated when the program ends. It's known as static duration. And it does not go out of scope anywhere in your application. So even though you get to the end of curly brackets or a method returns or something, your static members do not go out of scope. They exist for as long as the program exists. As I said, the memory is allocated when the program begins and deallocated when the program ends. They do not ever go out of scope within your application. And that is why a static method can only access static data members, because if your data member is not static, then its memory would not be allocated when the program begins, but the memory for the static method would be allocated, and you would then be in a position where your static method could call a data member that actually doesn't exist yet because it hasn't been initialized. So once you have a static method, it can only access a static data members. So that's just a bit of background about static. And so it's quite important for the singleton pattern. Okay, the singleton pattern. The intent of the singleton pattern is to ensure that a class has only a single instance, and then to also provide a global point of access to it. And this is, in fact, one of the criticisms of the singleton pattern. It's often described as being a glorified global variable, and global variables are considered to be bad. But the intent of a single pattern is to ensure that a class only has one instance, and then it also provides a global point of access to that instance, so you can access it easily from anywhere. Applicability: you use a singleton when they can or must only be one instance of a class, and it must be accessible from a well-known or easily accessible access point. That is, in fact, one of the advantages of the singleton. It's easy to access. Then there's no UML diagram for this because it's straightforward. So we just have this class implementation here. Class called singleton. Remember, underline means it's static. So it has a static private member which holds a pointer to the singleton. In other words, it holds a pointer to itself. Then notice the important thing, the constructor is private. That's crucial for singleton. And in fact, as soon as you get any kind of exam or assignment question and you see a private constructor, you must start thinking singleton. Then it has a public method, which is often called get instance or just instance. It doesn't have to be that. It can be called anything else, but that's probably the most common. And that returns a pointer to a singleton, in other words, a pointer to itself. And then I've represented the rest of the functionality of this class just with do something. So there'd still be various other methods and data members for the class to do what it normally does. But the required items for your singleton is a private data member, which is static, which holds a pointer to the singleton or to itself. It has a private constructor, and it has a public method, usually called get instance or instance, which is also static, and that returns a pointer to the singleton or to itself. And then just to summarize again, the constructor is private. The data member, often called instance, is static, and it stores a pointer to the singleton object. I've said they're optional because there's actually two ways of doing this, which I will show you shortly. Then it has a method, usually called get instance, which is also static, and returns a pointer to a new instance if one does not exist, or pointer to the existing instance if one does exist. And that is how, and I'll show you the code shortly, that is how it ensures that there's never more than one. So if one does not exist, it instantiates it and returns a pointer to the new instance. However, if there is one existing already, then it simply returns a pointer to that same instance. So you can never create or instantiate more than one singleton. Okay, some code. So there's two ways of implementing this. This first one is using the class member, a static class member, data member, to hold the singleton instance. And I'll show you another example using a local variable. But your class is straightforward. You have your public static method, get instance, that returns a pointer to the singleton. Then you have your private constructor and a private data member that stores a pointer to the singleton instance. And the get instance method and the instance data member are both static. Then moving across the right-hand side, I'll come back to the left again. This is in the source file. Remember, your class static members must be initialized outside of the class. The normal place is to put it in your source file at the top. So you use the scope resolution operator, singleton. Sorry, my mouse is a bit sensitive. Use the scope resolution operator, then the name, that's the name from over there, and you assign it the value 0. You could also assign a null pointer, which is probably better, and its type is a singleton pointer. So that is where you initialize that. Then in this example, in the constructor, I'll just put some output there to show when a singleton is instantiated. And then the get instance, and this is the important part because this is where it all happens. It says if not instance, in other words, if that is null or 0, this evaluates to true. and the instance is then assigned the value of a new singleton. And then it returns instance. So only if no singleton has been instantiated is this line ever called here. But as soon as that is executed, instance then gets a value, and it'll never come back in here because that will always then evaluate to false. So it always returns the same pointer to the same object. It never creates or instantiates another object once it's happened the first time. And then just looking at some examples, if we did put this code in main, if we declare a pointer to a singleton 1, and we call the get instance method, and then we put this code showing the output singleton 1 address, and we showed the address of that singleton. Remember, a pointer holds a memory address. You would see a memory address there. Then if we declared a second one and called get instance again, I've left the next line out here because there isn't enough space, but if you did put the same code here for that second one, you would see that they both output exactly the same memory address, which just proves that they are in fact the same object and they've been instantiated at the same memory address. But briefly, that's how singleton works, using a class member to store your pointer to your instance object. Then the variation is very similar, but it uses a local data member instead. So you still have your public get instance method, and you have a private constructor, but there's no class member here to store your singleton instance. And if we look at our source file, again, same constructor. Then our get instance method, the difference here now is we initialize our instance data member within this get instance method. So it's declared static, return type a singleton pointer, instance is assigned 0 or null pointer, then exactly the same thing. If that's null the first time it comes here, then it calls new on the singleton, and instance gets a value, a memory address, and that gets returned. The second time that this method gets called, this initialization line is ignored. Remember, because it's static, it only gets called the first time that it's executed. Then on every other instance, this will always return false because instance holds a memory address, so it'll just then return that same memory address. And that quite simply is how the singleton works. So there's two variations, either using a local data member or a class data member. But basically the way it's set up is it always returns a pointer to the same instance, no matter how many times you call it. And that ensures that there is always only one singleton object ever instantiated. Okay, then just to point out a difficulty, and it's quite a big difficulty with the singleton pattern. In fact, I'm going to go back to the other one. You're declaring a pointer in your class. And as you all know, you need to deal with pointers to release the memory. The problem with the singleton is that the pointer is pointing at itself. So you can't just put it in a destructor, because if you call delete on the pointer in the destructor, the first thing it does before it releases the memory is call the destructor. And of course, when that destructor gets called, the first thing it does again is call the destructor again. So you'll just be in an endless loop. So you can't deal with releasing the memory to this pointer from within your singleton object. You've got to handle it externally in your client code. So please remember that remember you always have to release your pointers to free the memory. And you know, when memory leaks, so bear in mind that this pointer you always have to deal with outside of your singleton object. You cannot handle that within the destructor of your singleton class. For the simple reason that it's pointing to itself, and you'll just end up in an endless loop. And that's quite an important aspect, because a lot of the sources, in fact, very few, if any, will actually mention that. In fact, I don't recall seeing anything about that in any of the other sources that I've looked at. So just bear that in mind. It is quite an important consideration for the singleton. Okay, then we're going to move on to the memento. Any questions on the singleton so far? No questions at all. This must be too easy.
There are questions in the chat.
Are there? Oh, okay, sorry, I wasn't showing. Okay, question from Hannah. What is the client in the abstract factory pattern? That's your application. Whatever the client is always the main application that is using these classes that we're referring to. More nice question. Static go on the heap or stack? Only if you use new, then it goes on the heap. If you don't use new, then it goes on the stack. Static itself doesn't affect heap or stack. It's whether it's you instantiating the object with new or not. Hannah, why would a static method or member be used? Okay, I thought I explained that right at the beginning. You use a static method or member because it has static scope. It doesn't belong to an object, it belongs to the class. And also because static local members are only initialized the first time they're called, and they hold their value between method calls, so they're never destroyed. So your value of the pointer to your singleton object is never lost because it's static. It lasts as long as the application lasts, not as long as the function or method that calls it. Can you make multiple singletons with different names? Well, yes, you can, but they'll all be pointing at the different, sorry, let me say that again. Yes, you can instantiate multiple singleton objects. You can give them 100 different names, but they'll all be pointing at the same object. So if you do something similar to the example I did, you'll see they all have the same memory address. So it doesn't matter how many times you instantiate it or how many different pointers you have pointing at it, they'll all be pointing at the same object. So there will only ever be one singleton. There can only be one. It doesn't matter how many pointers you have pointing at it, there is only one object. Moving on to the next question. Sorry, I'm just trying to read it. You can make multiple singletons of different, so I'm looking at George's question. You can make multiple singletons of different types. Yes, you can have multiple classes that are all themselves singletons, but for each one of them, you will only ever have one object instantiated. But within one singleton class, as it doesn't matter how many times you try and instantiate it, you'll always just get back a pointer to the original one. You will never actually instantiate another one. All right, that's all the questions. Okay, then moving on to the memento. Okay, this one, it's not actually difficult, but it can be quite tricky to implement it. Again, the best way to do this is to practice and do an example. Okay, memento pattern. The intent is to save and restore the previous state of an object without breaking encapsulation. And that's an important consideration of the memento, is without breaking encapsulation. I'm sure all of you will have used the memento pattern quite frequently, possibly without realize yet, but when you use a word processor or a spreadsheet with your undo facility, you are actually using the memento pattern. You are simply restoring the previous state of an object. And that is, in fact, the most common use of the memento pattern, is the do-undo functionality. Applicability: it's used when the state of an object needs to be saved so that it can later be restored, again, without breaking encapsulation. And as I said previously, it's the undo or backup and restore functionality. Okay, then memento is an object that stores a snapshot of the state of another object. So it's quite simple. A memento is simply an object that stores the state of another object. And we'll have a look at what the originator in that is over the next slide. But a memento can only be set or read by the originator itself. And the originator is the object whose state is being stored. And this is the encapsulation part. The originator or the object whose state is being stored is the only thing that can set or read the memento. And that's how encapsulation is preserved. It cannot be set or read externally. Or to sum that up, the originator has to be involved in saving and restoring its state. And that is basically to preserve encapsulation. So nobody else or no other class or object gets access to the state other than the originator, the object whose state has been stored, and the memento, which is the object that stores the state. Other than that, there's no access to anyone else. Okay, then your prescribed book, chapter 16.2, please note what it's describing there is not the memento pattern. What it's actually describing is the serializer pattern. And please don't mix up the serializer and memento. They're two very different things. The memento pattern is specifically to store the state of an object without breaking encapsulation. Serializer pattern is basically to serialize or communicate the state of an object, but it breaks encapsulation, which is one of the weaknesses of the serializer. We'll look at the differences shortly, but don't mix them up. Okay, this is the diagram. This is in your tutorial letter 105. Please have a look at it. But there's three parts to the memento pattern. There's the originator. That's the object whose state must be stored and restored. The memento is the object that actually stores the state of the originator. And then the caretaker is the one that initiates the whole process and then actually stores the memento. But as we look at now, a very important consideration is that the caretaker, even though it's responsible for initiating the creating a memento and returning the memento and storing the memento, the caretaker cannot actually access the memento. And we'll look at how that works now. But that's quite important. The caretaker is like the controller, if you like. It controls the whole process of creating and returning mementos, and it stores the memento, but it cannot access the memento. All it knows is that it's storing memento, but it's got no idea and no means of accessing what is actually in that memento. And that is, again, how encapsulation is preserved. Okay, then. So going through more or less the same stuff again. The originator is the object whose state is to be saved. And the originator, it saves itself. It calls it create memento method and returns a new memento. And then also restores itself. It uses a set memento method, which sets the memento. So all these different methods that can be quite confusing. So please read through the prescribed books in tutorial letter 105 and code an example. It's the easiest way to sort it out. But some of these method names here are very similar, and they get quite confusing which one you need to call when. So work through an example to get to. Then the caretaker is the object that stores or initiates mementos. It cannot access the memento, and that's very important. It preserves encapsulation. Then the memento itself is the object that stores or restores the state of the originator object. It sets the state of the memento. It has a set state method. It receives the state of the memento with a get state method. Then the important thing about a memento, all its methods and properties are private, including its constructor. And then how it operates then is you declare the originator to be a friend of the memento. So it can access all the functionality of the memento. So important part of the memento is that everything in the memento class is private, and then you declare the originator to be a friend of the memento. That gives it access. But then only the memento and the originator can access anything to do with the memento. No other class, and particularly the caretaker, can have that access, basically because everything in the memento is private. Okay, and once again, do an example, otherwise you get yourself quite confused. I'm actually getting myself quite confused. But this more or less is the process. The caretaker originates the whole thing. So it calls a method, and they don't have to be exactly these names, but these are fairly common, calls a save state method, which causes the originator then to call a create memento method. And that in turn gets the memento class to call its set state method. In this case, we're just using a string list to store the state. And these three can, in fact, you can just chain them. So you would generally have one line of code here. We'd have caretaker, save state, then originator, create memento, and then memento, set state. And then the reverse happens. The caretaker originates the restore state process. It in turn gets the originator to call it set memento method, and that in turn gets the memento object to call its get state method, which returns the state then to the originator. So it's actually a fairly simple process. It's just chaining these methods one after the other. But please work through an example, because as I've said, it can be quite confusing to work out which one you have to call when. But basically it goes from caretaker to originator to memento. And then the reverse process again, caretaker to originator to memento. And looking at some of the code here, this is typical code. It doesn't have to be exactly like this, but your main class, the one that you want to store the state of, called the originator, it's a normal class which has a set memento method and a create memento method. And in this case, we're just representing its state with some QString values, which we're going to store in a string list. You would obviously more likely get more complicated examples than this. So this is fairly simplistic. But basically, we want to create mementos by storing the state of those 4 strings. And that's the header file. Then if we look at the source file, the set memento method, we represent the state with the string list. And then we use the get state method of the memento to return that state. Sorry, I'm working backwards here. And then you use that state string list to restore the values of your strings, which are your class members of your originator. So this is when you are returning the memento. I should probably have started with this one here. Creating the memento, you declare your string list, the state of your originator. You then append all the values of your strings, in other words, the state of the originator to that state. You then instantiate a memento or pointer, then use new, and then you set the state of that memento by passing it the string list that you just created, and that returns that memento. So here you've created or instantiated a memento object, you've set the state into the memento, and then you return the memento, which in fact goes to the caretaker. Then your memento class, notice everything is private. Your constructor is private. You have a get state and set state methods, which do the normal, and then you have a data member that stores the state. In this case, it's just a string list. And then to make it all work, you declare the originator to be a friend of the originator. So everything in the memento is private. That's quite an important thing to know. Then the implementation of your memento is just a straightforward getters and setters, which either return or set the state of that string list. So the memento itself is a very simple class, and you shouldn't have any problems with that. Okay, then looking at the caretaker. The caretaker, again, you have its constructor and then methods to save and restore its state. And you also then have a data member to store the memento. There are different ways of implementing this. In this case, we've used a pointer to the originator so that the caretaker can access the originator and knows which object it is. Then looking at the source file, straightforward constructor. Again, save and restore state are basic getters and setters. But notice that they call the methods from the originator. That's why we have that pointer there, so we can access the originator. So your caretaker calls the create memento method from the originator, and it calls the set memento method from the originator to either save or restore the state of that memento. So it's not a difficult design pattern, but it is, I think, quite confusing when you're just looking at it like this, and you probably need to sit down and work through it fairly carefully. It's just a matter of getting the process and the procedure correct, but there's nothing overly complicated about it. Sorry, we're jumping around a bit. But the important part, I think, is your memento class and understanding this part, where everything is private, including the constructor, and where you declare the originator to be a friend of the class. Excuse me. So this is probably the most important part of the whole memento pattern, is understanding how the memento works, and this aspect of enemy private and declaring the originator to be a friend. So I just want to go back one step here. In implementing the memento pattern, remember we said earlier that design patterns are not necessarily a strict implementation, it's more a methodology. You will often find that the caretaker is not in fact a separate class, that just gets, should I say, included into the client, or in fact the client plays the role of the caretaker. So you won't always see, in fact, a separate caretaker class as such. So the role is often fulfilled by the client, and it can be done by the client directly, or you could do it by having a caretaker class and then using composition to include it into the client. But you will always have an originator, which, just remember, won't be called an originator. It will be whatever its actual class name is. The memento is generally called a memento. And then you would either have a caretaker specifically, or else the client class taking the role of caretaker. So just remember that you won't initially see in implementations of the memento pattern see a class actually called caretaker, or see a class actually called originator. In fact, you will probably never see one called originator, only in academic examples. But that class name originator will be whatever the actual class name is, whose state you want to save and restore. But yeah, just once again, please do the exercises, particularly exercise 8. You will get practice at doing all of these. Yeah, George, using a keyboard might work in 7 cents a month, except the keyboard doesn't scroll as easily as the mouse. Okay, strategy pattern. Okay, this is one you need to know about. As I say, it was included in the exam last year. The intent of the strategy pattern is where you have a family of algorithms that need to be made interchangeable based on the context. Then the applicability enables the selection of algorithm at runtime. Note that, that's quite important. So you can change what your application does at runtime. You can make it do something different. In models and views, you can use the strategy pattern to display different views, for example, so you don't have to use the same view all the time. Then when you want to define a family of algorithms, encapsulate each one. Then you need an abstract base class and inheritance for concrete classes. As you'll see, this is actually very similar to the factory method. In fact, it is often used in conjunction with the factory method. Then the other thing is where you have these different algorithms and you want to make them interchangeable, the context, which is basically your client again, keeps reference or pointer to the strategy objects, and then it selects whichever one it wants to use when required. And again, it uses these principles that we've looked at before, composition and polymorphism, because you have multiple strategies which would be use inheritance and polymorphism. And the advantage then of the strategy pattern is it allows the algorithms used to vary independently from the clients that use it. So you can have a client and you can change basically the functionality of your client code on the fly while it's running. Just to give an example, in last year's assignments, we had a question which used the strategy pattern where you had to sort some data, and we used the strategy pattern to call different sorting methods. So you could run your application, sort it using sorting method A, then you could on the fly select a different sorting method and sort the data again using the second sorting method. So the strategy pattern basically gives you the ability to change the way your application operates at runtime. You can literally change your application on the fly to do different things. So that was an example where you can call different sorting methods. Another common one you'll see is when you have models and views and you want to get a different view on your model data, you can simply use the strategy pattern to call or implement or change your views, to put it that way. So the strategy pattern basically allows you to use interchangeable algorithms and change it on the fly. Okay, looking at the UML diagram, and then similar to the memento pattern, this context is, in fact, I'd say more often than not really a separate class. That context will actually be in your client code. There isn't, it's a very simple class and there's no real need for it necessarily to be separate. So just bear in mind that your client class often fulfills the role of this context class. And then all you do is you've got an inheritance hierarchy, you've got an abstract base class for your strategy, and then you have various derived classes which use polymorphism to do different things. So there's nothing really tricky with the strategy. But just looking at these items briefly, right, your strategy class, which is abstract, declares a common interface for all your algorithms, or in functionality and subclasses, to put it a different way. Then the context, which so more often than not is actually your client code. It uses this interface, your strategy, to call the algorithm as defined by a concrete strategy. Then your concrete strategy that implements the algorithm using the interface defined by the strategy. And when we say implements the algorithm, it would generally just be a method within the class. So don't be distracted by using the term algorithm, and that's what they use in the documentation. But it would just call, in fact, a different overridden method using polymorphism in your subclasses. Then your client code instantiates and passes the concrete strategy object to the context, and that interacts with the context. As say, your context is often included into the client. It's not very often that you'll see them as being separate classes. Then this is something you'll see quite often. The strategy pattern and the factory method actually get combined. So you have your client, and that uses the context, as that's often included in the client, which in turn uses your strategy, the abstract base class. And then there's different derived classes for your different strategies. And then the way you can implement those different strategies is by using a strategy factory. So this is in fact the factory method, which you would then use to instantiate your different strategies. So your strategy pattern and the factory method you will often find combined together. They work quite well. Sorry, my cat is now arrived. Stop sleeping.
Yes, the cat. We want to see the cat.
I don't know if there's an easy way to do that. No, cat, off the keyboard. There is a video on my Unisa, and sorry, cat, sit down. No, she's about to step on the keyboard. Okay, there's a video on my Unisa for this strategy pattern, which shows this combined strategy in factory. Please have a look at that. It probably explain it a lot clearer than I'm able to. Please make the effort to look at the prescribed books and the videos. These design patterns are not complicated. It's just a bit difficult to explain them at times. And so the best way to come to terms with them is probably to actually write some code and do examples. Okay, then the facade pattern, you don't really need to know too much about this one. The intent, sorry, cat, sit down. The intent is to hide the complexity of a system by providing a simplified interface for client access. I think this diagram actually explains it all. You have your facade, which encompasses a whole lot of complex functionality, and then your clients only have to interact with the simplified interface of the facade. But everything, the complexity internally is hidden away by your facade pattern. So the applicability is it's used to provide a simplified interface to a complicated set of systems. The facade interacts with the subsystems based on requests from the clients. And the high-level interface that makes subsystems easy to use. So basically what the facade does is it hides all the complexity away from the user and handles that for you. The user, or the clients in this case, only have to deal with a simplified facade. So it's quite a useful pattern, but it's very rare that this, I've seen this come up in the exams or assignments. So just read up about it, have an idea of what it does, but you don't need to know huge detail about it. And then serializer, I'm not going to go through again because we've covered that before. The serializer is used to serialize or stream the state of objects into or out of other objects. So it's a means of communication. And just remember, the main thing about the serializer is that there's two classes, a reader and a writer. They must be separate classes. Do not make the mistake of having one class with read and write methods. But you should be familiar with the serializer by now. Then the adapter and wrapper pattern, again, it's another one. Just have a brief idea of what it's about. You don't need to know any detail about this. But it's very similar to the facade pattern. It simply converts the interface of an existing class into another. And the idea behind this is that you use it if, say, you have existing class which has an interface which is not really compatible with your existing classes or your existing application. You would then use an adapter wrapper pattern that's known by either name, simply to wrap that around the existing problematic class and provide it with an easier or more suitable interface. And then the idea of this is simply lets classes work together that couldn't work together otherwise due to incompatible interfaces. So it's just a nice wrapper around another class that makes it easier to use. As I say, it's very similar to the facade pattern. But you don't need to know huge detail about this, just have an idea of what it does, read what's in the prescribed book. Okay, then looking briefly at the serializer versus the memento. So don't get them confused. Unfortunately, your prescribed book does get them confused. The serializer is used mainly for the communication. I'll get this right eventually. It's mainly for communication of the object state, whereas a memento is used to save and restore the state of an object. And this saving and restoring the state of an object, more often than not, it's done in memory, although I suppose it could be written to file if necessary, if you're using large amounts of data or something. But yeah, so don't confuse the serializer and the memento, and don't get the idea that serializer is used for backing up just because we've done examples with reading and writing to files. And so that was just to give us somewhere to communicate to. Then the criticism of the serializer is that it breaks encapsulation, whereas a memento very strictly preserves encapsulation. Then in the serialization and deserialization is done by external classes. In other words, your serializer is external. In a memento pattern, the state is saved and restored by the class itself, the originator. So that's an important consideration. For the memento, the originator has to be involved in saving and restoring its state, whereas in the serializer, it's the exact opposite. The class itself does not participate in the process. It's done by an external serialization classes. And just to complicate things slightly, is the memento pattern can in fact use serialization, deserialization to save and restore its state. So it's not impossible that you have a case where you have a memento pattern that actually uses the serializer pattern to save and restore the state. But don't worry about that aspect too much. I don't think you get a question on that, but just bear in mind that that is a possibility. And the singleton versus the monostate. And before I carry on with this, please have a look at this book, The Principles, Patterns, and Practices of Agile Software Development by Robert C. Martin or Uncle Bob. There is a PDF. If you Google for it, you'll find it quite easily. It discusses exactly what I've got here in a little bit more detail, the singleton and monostate. It's a PDF by Robert C. Martin. No doubt Mornay will post the link within a couple of minutes. But please have a look at that. It's quite interesting. Also, if you look at Stack Overflow, you'll see there's actually a lot of discussions about singletons versus monostates and which is better. They actually get quite heated at times. The last time I looked, I think the monostate guys were sort of winning. But there's some quite interesting conversations, quite in-depth conversations there if you want to have a look at that and get some more in-depth knowledge. But briefly, singleton versus the monostate. A singleton enforces the structure of singularity. In other words, it's built into the class. That's by using the static and returning a pointer to the same object all the time, whereas the monostate enforces behavior of singularity. In a singleton, you have one and only one object. That's how it makes it a singleton. Whereas a monostate, you have any number of objects, but they all have the same state. So the monostate pattern enforces behavior, whereas a singleton enforces a single structure. And the singleton can be created through inheritance. A monostate cannot be created through inheritance. Then a singleton cannot be inherited. That's because it's got a private constructor, and you also need to add the static methods and variables and so on. You can't override static methods, but there's a logical problem with this. As soon as, if you could inherit it, it would no longer be a singleton because there would then be two of them. So you cannot inherit a singleton. Whereas the monostate pattern, you can inherit from a monostate class. That derived class is monostate. Just notice the difference here. You cannot create a monostate class through inheritance, but you can inherit from one that is already monostate, and that derived class will be monostate. So it's only the initial part that you cannot do. Then singletons are not transparent. Your users know it's a singleton simply because you have to use that get instance method to instantiate it. So it's obvious that you're dealing with something different. Whereas the monostate, a user would not know that it's monostate simply because you do instantiation in the normal way. And it doesn't matter how many times you instantiate objects, it will still look normal to a user. It's just that they'll all, although you'll have multiple objects, they all have the same state. But as I say, have a look at Uncle Bob's article for a little bit more detailed information about this using inheritance and so on with singletons and monostates. It describes it in a bit more detail and probably a bit clearer than I have done. But it's worth looking at this article. It's only about 10 pages. It's not too long, but I think it's quite interesting. Okay, then looking briefly at past papers. This is from October, November 2020. This question paper had a scenario that was based on a hospital admin system. And the question was, it could be argued that a model to manage all hospital beds should be a singleton. What would you consider to be a convincing argument in this scenario? So you just have to have a bit of a think there about why you would need a singleton, but I think it's quite obvious. You wouldn't want a situation where there's two lists of hospital beds which had different number of beds and showing different beds occupied and not occupied and so on. So that would be an example of where singleton would be useful. Then this next question, code being provided to ensure the singleton design pattern. Does this meet the requirements of the classic singleton pattern? If you look at this code here, you'll see it obviously doesn't meet the requirements for the singleton. And you would just need to fix that up to make it comply with the classic singleton design pattern. So that's not very difficult. I think another 4 easy marks. That's just a brief idea of what you'd get in question papers. Then this one's a bit more complicated. You were given a UML diagram and the create memento function with the code. Then using this code as a guideline, you have to give the class declaration for the bed memento class that follows the classic memento design pattern. So you would need to implement the class for the actual memento and not this originator code. So that's just an idea of what you would need to do for memento patterns to give an idea of the depth of knowledge you required. And then just to finish off, please read tutorial letter 105. There is some information in there. Prescribed book, just give it a quick read. Don't bother too much with it, but get an idea of what's there. Do exercise 8 in particular, and look at the past papers and also the recommended books and that article from Uncle Bob. So that briefly then is what you need to know about design patterns. Any questions on that? Sorry, I'm just going to go back here a bit. Question: is a singleton can be created through inheritance?
Yes.
No, you're not inheriting. Sorry, I'm answering this question from Percival. You can inherit a class and turn it into a singleton. It's not the same as inheriting a class that is already a singleton. So you can create a singleton through inheritance. In other words, you take a class that's not a singleton and you make it into a singleton. So the issue of private constructor, that doesn't come into it. Any other questions? Oops.
Yes, I had another question.
Okay.
On the memento design pattern, on whether if we added a get memento method, would that allow the originator to double hat as a caretaker?
No, the originator can't fulfill both roles. Sorry, I'm just trying to get back.
So if you
the caretaker and the originator must be completely separate. The caretaker has to store the state of the originator. The originator already knows its state, so it defeats the objective of the memento. There's no point in the originator storing its own state. It already knows its own state. The idea is to keep its state separate so that you can revert to its original state again, even though that might change in the interim.
Okay, so initially when it sets its state, it's sort of taking a bit of the role of the caretaker at the initial moment.
No, the caretaker is the one that initiates the process. The caretaker basically instructs the originator to save its state. The originator then sets up the memento and passes its state to the memento, and then returns the memento to the caretaker. And the caretaker then stores the memento. And when the caretaker decides it's time to give it back, the caretaker then returns the memento to the originator. The originator then uses the methods from the memento to restore the memento state to the originator state. It's slightly complicated to pick up at first. The best way is to go through an example. You've just got to get used to the chain of commands. But it goes from caretaker to originator to memento. And each of them calls the next one in turn.
Okay.
Any other questions? Nothing.
Sir,
Yes.
I wanted to know with the memento pattern on the serializer. When we're given a scenario to know whether to use the memento or the serializer, is it only based on encapsulation? Is that the difference?
That is one of the biggest differences, but now they've got two completely different purposes. The serializer is to communicate the state of an object. It's not to store or back up the state. Serializer is for communication. The memento pattern is to store and restore the state of an object. So the fact that we've been doing examples with the serializer of writing to file is incidental. That's not actually the purpose of the serializer. We were just using files to give us a device to pass the state to. But the serializer is not used for generally for backing up or storing the state of objects. It's for communication.
Okay, thank you.
Okay. Okay, if there's nothing else, we'll be ending there, and then I'll send out a notice. We'll have a class next week going through assignment 1 solutions and exercise 5 solutions. It'll be basically entirely code-based. Okay, then that's it. Thanks, guys. I'll send out the notice for next week.
All right, cheers.
Yeah.
Thank you.
Thank you, Ron. Have a nice evening.
Mhm.